hit the live button.
Pax Gloria, wait.
Alright. Thanks everyone. Welcome to another Common Lisp study group. This is Ron Vadum with Atlanta Functional Programming. Today we're going to finish off our discussion on closure-oriented programming and begin our discussion on just a general review of macros. According to Doug Hoyt's book, Let Over Lambda, we're going to be covering, hopefully, finish off Chapter 3 today, because then the real fun stuff begins, starting next week after this little review. Get started, I just wanted to at least give one, more, kind of like plug for the Lisp Game Jam coming in a couple of weeks on, what was it, April 18th?
19th?
It was 19th or 18th. I was looking at it earlier. It is April 18th. April 18th at 10 p.m. till April 29th, 9:59. You can register for it. There's a link on the Lisp Reddit. I will go ahead and post that as part of this YouTube video once we're done, so that folks who want to register for it can do so. It's going to be a fun time. You can write in any common any Lisp you want, common Lisp scheme, Emacs, closure, or if you found some weird Lisp that nobody has found that has some interesting features, go write it in that too as well, like Highlang or whatever. I'd be interested in seeing some of that too. Of course, Atlanta Functional Programming is a group that promotes the functional programming paradigm across the Atlanta area. And now we're kind of reaching out to other cities too. We normally host a monthly talk over at the Atlanta Technology Development Center, which is the ATDC in Tech Square at near Georgia Tech, once every month. Look at our meetup pages online for more information. We also have our YouTube channel that hosts streaming video as well. Thought I'd at least, plug a couple of those in before we get started. Last week we kind of stopped at, kind of special environments and kind of an introduction to closures, just a bit of a review of what closures are, which are, kind of a binding of local variables in a lexical environment, and you can actually have functions reference those variables in their code. The classical example of a lexical closure is that most people end up, kind of when they're being introduced to lexical closures, that is, are introduced as building a counter. This is an example here that I've grabbed from Doug Hoyt's book, just for good reference. That, it's pretty simple. All it does is it sets a parameter counter to 0, and then it creates an anonymous function that increments that counter. Nothing spectacular. If you compile this and you go in and I forgot to change my package to AFP. Oops. 1 second. I forgot to load this. And AFP. Yeah, now I can do this. So if you compile this and you try to look into this counter, you'll notice that this will reference a closure in memory that that has this anonymous function kind of instantiated. If you want to actually call the anonymous function, since it's an unnamed function, and it's specified under a and by unnamed I mean it's not an interned symbol. You have to use funcall to actually go in and call this guy. And when you do so, it'll go and invoke it, recognize that it has access to the counter variable, and it will go ahead and increment the counter variable. Nothing spectacular here. This is kind of a review. Obviously, you'd want to be able to create these things, on the fly, these kind of closures on the fly. But the way we wrote it here isn't necessarily conducive to that. Well, you can easily take this code and make it into a function that is that could create these new instances, so to speak, of this counter closure, and that's through just wrapping this closure variable around an anonymous function. Now, this is kind of it blew my mind when I first saw this, and that, oh wait, so this makes it pretty easy that you create a function that will allow you to create closures at each time, and you have the same instances specified. You could totally specify parameters in and set that up to create a closure that treats those parameters like instance variables, and you can have a series of functions that reference those instance variables. That's nothing more than what modern programming languages call class definition and class instantiation. I mean, of course, with lambdas you have the ability to create what are called anonymous classes. Now, I think this would be considered different than what most people probably hear anonymous classes when inner classes in like languages like Java, primarily because those classes are named. Those class definitions are named. You can instantiate them. You don't have to have a variable associated with that class, but the class definition that defines the structure of the object and its related methods, that's still actually named. In Common Lisp, at least, I think it's the same in Scheme 2 as well when it comes to closures too. You don't need to necessarily specify a name to an anonymous function that generates additional functions like this. So you could assign this to a variable, like we did earlier, and this would be, if I can type, this would be our counter constructor, so to speak, and it will just go ahead and if you call this guy, this will, using fun call, of course, it will constantly provide you new oops, oh, sorry, constructor. It'll call the Lambda closure. It'll return a closure for you every time that resets the counter variable and gives you a new counter. So if you fun call, what we saw earlier, it will just go ahead and increment the same counter variable. And if you call this guy again, you'll see this is a new closure itself that also will have a new reset counter variable. This is all kind of not new to folks who started playing around with this, but this kind of pattern of creating closures and then creating lambdas that generate closures, that when I first started encountering this in Common Lisp, that kind of changed some perception for how I could potentially design a system without really having to go into creating like an inheritance hierarchy, or kind of following some of the more standard OO idioms that most of us are very familiar with when coming from modern programming languages. Of course, we don't. This kind of idea of not naming the lambda over let over lambda is sometimes is not conducive to like maintenance. So often you can actually just go ahead and use defun to go ahead and create this closure. And defun, it actually has, if you recall, it actually creates an implicit lambda underneath and returns it. Object systems use a lot of these kinds of like closure kind of techniques behind the scenes, and they end up doing kind of the same thing, and actually ended up being the same equivalent code. But this style of incrementing and creating let over lambdas and closures is a different design paradigm, unique to a lot of the Lisp family of languages. Uh, of course, we can even go further than just creating constructors and lambdas. We can actually also have class variables and shared variables and implement you know the same idea of class and shared variables by taking this lambda over lambda and actually wrapping it around another let, and we now have the ability to, if I can actually type, we now have the ability to now share class variables here, if you can see here. And the example that Mr. Hoyt used in his book was a very nice thing. Like, you can actually, of course, set up a class variable to decide whether or not this counter needs to increment or decrement, and what it will do behind the scenes. We could write a function that will ultimately, check to see if the class variable is set to up or the class variable is set to down. So we can, create this function here that checks. Let's do this. If EQ direction up, increment, otherwise we decrement the counter. So this little example, all it does is it creates a closure called make counter, and it will go ahead and it will return a closure that checks the direction variable, and if it doesn't, if it's set to increment, it'll go ahead and increment the counter. Otherwise, it will decrement it. Now, of course, we can also make additional functions that reference the same variable. Like, let's say that we have one called, toggle direction. That all it does is, if let's see, if EQ direction up, go ahead and set F direction to be down, else. And this simple function here will allow us to now, toggle the direction before we make new instances of this counter. So if we go in and start with a simple def parameter counter make counter, oops, sorry Elijah, I forgot the second earmuffs there. I know you're a stickler on the earmuffs, so I'm trying to make sure.
At least you have one.
Yeah. It's clear something's going on there.
People.
Yeah.
You can now, call this function, and it will increment it. And you could toggle the direction. Let's say that. And now, if we call counter, it'll decrement it, as you can see right here. So what we've done here, and this is kind of a shocker to first people coming into Lisp who's never who's coming from like Java or Python or something like that. We've written a very primitive, doesn't have everything, but a very primitive object system that could allow you to, that has encapsulation, because you can't access the counter variable outside. It has methods that can access those variables, and you could perceive using this to even do basic object composition, which is now being kind of encouraged to do instead of strict inheritance hierarchies. This is why in that book, that quote by Guy Steele is something to really think about, and that is, as long as you have con cells or assignable value cells, and lambda expressions that are properly ingrained into the language, you can actually, in according to Hoyt, the environment, which I'm guessing is kind of an, it's above this kind of scoping that you think about when you normally talk about lexical and dynamic scoping. You can pretty much solve a lot of the majority of major problems that we would have. You can actually design around them and make new problem domains. And it is this technique that we'll be using as we start really getting into macros. So let's review macros. There's a lot of examples that he provided in here that I'm not entirely sure. I mean, some of them are contrived, but would you guys like to just go through some of these examples? Folks who are on the stream. Hello, Bueller.
Yeah, I think it'd be nice. I mean, I forget exactly what examples he does there, so I don't really have an opinion either way.
Well, we got the with gensims and the once only, and then he gets into reader macros with CLPCRE.
Yeah.
Oh yeah.
He goes through.
Isn't it actually CLPPCRE?
Yes.
Yes.
Yeah.
So let's go through this one at a time. So one thing to get started with, this is a very basic macro that I like to start that he gave, and it also gives some of the notation differences that I have to get used to again. But the example that he started with is a simple one that essentially
before you go any further.
Yeah.
You have an extra close paren at the end of your make counter definition.
Yes, I just noticed that. Okay. I'm going to be checking in this code, so eventually I'm going to be getting complaints. So when people start running it, oh, there's a bug here and there's a bug there. Okay.
That's the trouble with live coding.
So the example he gave was a pretty standard example that of how people get started when they start using the sleep function. Like I remember making this kind of convenient function when I was using sleep, at least in C, because sometimes it's a pain in the butt to constantly remember. Okay, I got to change this to seconds. So what you would sometimes do is make these dumb little utility functions, but you end up with macros end up making them more general enough that you could just specify the units. So this is a common function that a lot of folks start when they build, when they start learning about sleep and recognize it's only dealing with seconds, but you can't specify minutes. So you end up writing this function so that your code is a little bit more, understanding as to why you're, using constants to convert something into seconds or not. It's easier just to say sleep minutes, 5 minutes, and then people will know, okay, he's passing in 300 because the function will specify 300. But let's say that you end up changing it to hours or days or what have you, right? The simple idea that he said is well, you could just go ahead and define a function that takes in let's say we call it sleep unit, and this notation here, this percent sign, for folks who we've talked about this in previous CL study groups, but a review, that's saying that this is it is implementation specific. There's a standard on how
no, he actually declared the percent trailing symbol there as unfinished.
Unfinished.
He will iteratively build upon the function until it's complete, and then he'll remove the percent symbol.
Yeah, it was a version where he keeps appending a percent signs until it's complete and then he removes them.
Oh, well, I was reading this as the percent sign, and he says he will, on page 42, he says that we'll replace it with a macro that doesn't have the percent sign. So I was thinking that there was a difference between that, but I didn't.
He explains it in the first chapter somewhere about just a convention he uses for the book. Okay. What you're thinking about is the leading percent sign, and that's just a convention in Common Lisp in general, where it represents a low-level function or possibly unsafe to use.
Okay, got it. So you're saying that not this. This is saying that's low.
Convention. It just represents, probably not the exported symbol that you want to be using. It's usually like a low-level function that is called on by the high-level function, I guess. Or it could represent unsafe code. Basically means probably shouldn't be using it as a user.
Okay. All right. So this percent sign is really saying that he's unfinishing. It's an unfinished function that right. that he's just using to indicate that this is like a draft. So he might add more drafts.
Yep.
Okay, got it. So in the sleep unit draft of his function, he calls sleep and he multiplies value with a case statement that he leverages. And this case statement takes in the unit, and for each case, like he specifies, and I'm only going to mention a couple of these. For example, the book has plenty of them, so I encourage you to read the book and get the full implementation of this. But this is just to show off what he was thinking. This unit case statement essentially takes in the unit value, and depending upon what was passed in, it'll return a specific, constant that is then multiplied by value and passed into sleep. Now this is kind of it corresponds to kind of what a lot of folks do in like other languages like C, where you create, a constant for each or an enumerated type to specify what you are what you want to actually compute with, and based on what that unit is, it will then multiply value with the appropriate constant. Nothing new here, but the one thing that is a sticking point is by writing your function this way, what you need to do is what you end up realizing is you need to pass in the unit has a quoted symbol, and that's because if you don't, and I will just show this to you, if you do sleep unit, let's say percent 5 seconds, you'll see that this will work if it's quoted. If you end up not quoting it, what ends up happening is Common Lisp will treat this, and we reviewed this in our previous discussions, but Common Lisp, if you recall, will treat this as a symbol that needs to be looked up. It'll think it's a variable, and if it doesn't find it, it'll then throw up an error, and that's exactly what it does. It tells you that S is unbound, and that makes sense. It's an uninterned symbol that didn't have that wasn't bound to any specific value, so it couldn't go and return it and compute with it. So that's kind of ugly for folks who especially aren't familiar with how Common Lisp works, and you want to make it a usable API so that you don't have to think about always quoting the variable the units when you're passing in. So the way he solves this is if we remember what macros do not actually evaluate the arguments unless you not splice them. You explicitly force an eval, and I'm forgetting what it is that you have to do to actually force it. But we'll discuss that once I show you the second version of this code, which basically is essentially like the first version. It's a template that it's going to be creating that takes in the value, and then based on the unit that's passed in, it will. You can then just specify the unit as is like before, and so this looks the same, but you may notice that oh, I have to actually do this. That's one more thing. This guy needs to be unquoted because we want this to actually be not evaluated. If you end up not putting the comma before the splice operator before the case, what ends up happening is it will be evaluated. It will require that the unit be quoted, and we'll end up having the same function as before. So in order to not evaluate it, you put the splice operator in, and this guy will then just allow you to write things like this, which is 5.
That's actually the unquote operator.
The unquote operator. Oh, I'm sorry. Splice is comma at, right?
Correct.
Okay, yeah. I'm in the unquote operator. So you can see now you could just specify the units as is, and from a API standpoint, this is much more cleaner if one actually just looks at it. Sorry. If one just looks at this versus our draft that uses, I'll just say this, 0.5 seconds. You can see that this requires you to remember, the sleep units percent requires you to remember certain semantics on how the function needs to be invoked. Sleep units, you could just write it as if you're thinking about specifying a unit, and it will do the right thing. And this shows you one thing about macros that I thought was pretty cool, that the book doesn't necessarily discuss it, but I'm just going to mention it anyway, and that is it allows you to provide a way to create APIs and functions, and more importantly descriptions of how a solution should kind of look like, and it's as familiar as anybody who knows what S stands for, H stands for with respect to that function. They'd be able to read it and understand it. This is different than sleep units percent because it requires you to have a little bit understanding of the internals of the function representation as to what it's being passed to, what it has to be passed to, in order for you to actually invoke the function to get the correct behavior. Another example that he gave, and I think it's important for us to actually go through, is he actually goes and further refactors this, just to finish off the sleep units example. We can actually do, we can convert this guy into what's called a unit of time function, and but the code is kind of the same. So he basically, uses unit of time, where you specify the value and the unit, and it will return a constant for you instead, which is just this. And an example of this is if you do, let's say, unit of time 5 minutes, it will, Did I? Yeah, I forgot. Hold on, I have to stop this. Ugh. I compiled the wrong macro. Yeah. It will go and return you, the number of seconds associated with, that unit at a time. And you can use this to build higher level abstractions so that, sleep units will then just, take in, for example, the value in unit and it will call unit of time. So we can actually now take this guy, our defun, we could write sleep units again here as being just nothing more than sleep and unit of time value unit. And that clearly tells you what is going on. What? Oh, does not like the fact that I redefine this as a function. I have to unintern. 1 second. I have to unintern sleep units here.
Just compile it again and it'll stop complaining. You don't have to unintern anything.
You can also fmake unbound.
Just CC it again for comma CF in space max.
Oh, yeah. One style warning. Okay. Got it.
Detecting unreachable code. That's not right.
Unit of time. That is correct. What did I mess up?
Yeah. I
so
see
that function has a bug, that's all.
Yeah. Unit of time's expansion isn't right.
Unit of time expansion isn't...
Okay, so go to the place where you're using unit of time.
Okay.
Go to the very beginning of that. Like, go to the... Yeah, now. Expand that. Macro expand that.
That is...
Comma M... S, I think.
Okay, E. Is not a macro form.
There are extra parens in the code on unit of time and sleep units.
Oh.
No, there aren't, actually. Well, there might be an extra close paren at the end of unit of time.
Yeah, that's probably what it is. Yeah,
so
there you go.
That.
Now.
But sleep unit's still got a problem. So try macro expanding unit of time. Actually, I think macro step is not doing its job right now. Revert the buffer. Space B R, I think. Might be space B shift R.
Nope, that's not
it. Escape. Whichever one you hit, it's the other one. Yes.
Alright.
Now, yes. Revert the buffer. Now do comma MSE. There's a bug in macro step.
Ah, here we go.
Okay, yeah. See that?
Value nil. Yeah, I do. Yeah.
Okay.
Yeah.
So, do you know why?
It is because... no, I can't seem to see why.
Well, your case statement can return nil if none of the branches match.
Oh, shoot.
That you can do one of two things. You could, return a default branch, or you could splice it in.
Right, but that's not going to help at this point. The problem is that the unit isn't a compile time constant.
Right.
The unit of time macro only works when the unit argument is a compile time constant.
Right.
Because you're evaluating the case at compile time.
Right, and that's exactly what that's why he actually ended up using No, actually, he wrote it the same way, interestingly enough. Although I didn't write all of his units that he specified. That's interesting.
That code as it stands doesn't make any sense. The macro does, but the function doesn't. You can't write that function. That sleep units function.
So I can't write it this way? Work. Okay. No. So...
Because you're taking the unit as an argument.
Right.
But that macro needs the unit to be a compile time constant.
Right. So what I'm going to have to do is this is still a macro then, is what you're saying. This can't be...
Right. Correct.
And then...
Backquote that and unquote value in unit.
Yeah. That's right. Now this will work. What the heck? Oh.
Ought to anyway.
For some reason, it just stood there for a second, so I was wondering what was going on. So let me see here. Sleep units. 1 second. Should still work. Okay, it still works. And let me just do a macro expand here to make sure that SE. Oops. I have to go over.
Yeah, that's not going to work.
There we go.
Because you just macro expanded the backquote.
Yeah, that's right. That won't work.
You need to have a source form. You not a templated source form. You need
So
an actual
I have to do
source
this
form.
5 seconds. Now this should macro expand.
Correct.
Oops.
Go to the open paren. You have to go all the way out to the open paren.
Okay. There we go. That's right. And now I can actually go macro expand that. It recognizes that it's 1 and then it will generate out. Okay. All right. Okay. So I learned something today. Let's go to another example here, and that is control structures. One common control structure that most people are familiar with is so the let form that we have been using in Common Lisp. It's slightly different apparently than the scheme let form, and this is something I wanted to discuss because I don't know too much about scheme, so I wanted to bring it up to the discussion group to show some differences here as to why he implemented this named let. He says that in scheme, and this is on page 45 for folks who have the book, in scheme you can optionally insert a symbol before the bind list of a let form. Scheme will bind a function named by that provided symbol around the let body. I didn't quite exactly understand this example, this explanation.
So, named let is another way to do local recursion in scheme, basically.
Okay.
So what it does is, what's the best way of describing it? So
it's like labels, isn't it?
Well, it uses labels, the CL implementation uses labels.
Yes.
It binds a local function that can be recursive. Can it be recursive?
I think so, yes.
Yeah.
Yes, according to his example, the namelet implementation that he wrote, and it labels underneath and labels is recursive.
Yeah. Okay, but yeah, so the point is that that the function that it binds will have the same will have as arguments all of the variables from the let form, right? And so inside the body of the let, you can call that function to basically jump back up to the start of the let, but pass in different values for each of the variables.
Okay. So
if you ever see a case where you write a recursive, where the whole body of your function, right? You write a function, and the whole body of that function is you write another local recursive function, right? And then you just call that local recursive function.
Yeah, that's what you normally do if you want to do tail recursion, right? Like you do.
Right. That whole pattern is done using nlet in scheme.
Oh, okay. So whereas I use labels in Common Lisp, it's nlet in scheme that does.
Well, kind of. So in the specific case where you define one local function. Yeah. That's recursive, mm-hmm. And then you call that local function, and the body of your labels is just calling that local function.
Mm-hmm.
That pattern is nlet in scheme.
Got it. All right. All right. So let's go and look at how this is implemented.
In fact, if you read the implementation, it's literally exactly that. But well, I'll get to that in a moment.
Yeah, I think like a good example is like anything that uses like a continuation passing style.
Yeah.
Would, like, you know, anything where you have like an accumulator for like a tail recursion.
Yes. Just easier to write using let. This is also like very similar to, for anybody who does a closure's loop recur construct. Very similar construct.
Loop recur is and let, you're saying?
Very similar. Yes.
Very similar. Okay.
But really, what it is that loop recur in Clojure is nlet, but the name of your function is always recur.
Okay.
You don't get to provide a name for it. It's just always recur.
So the way the book describes their implementation of nlet, and I'm just implementing this straight out. This is on reference LOL page 45. Just so that folks who are following along and folks who actually look at this code wondering where the heck did he get this is where it's located. So that you can follow along in the book and then try some examples here once you get used to.
And that's not land of Lisp. We're talking about let over lambda.
Yes, we're talking about let over lambda. I never
lambda
read
over
lambda
let
Lisp.
over lambda. Let over lambda over let over lambda.
Hold on. Yeah, you can have let over lambda or let over lambda.
You could go as deep with that as you want.
Just remember, don't go that crazy.
I'll go as crazy as I want.
I don't know, man. It could. But let me just put this in.
I need a constructor factory, man.
You
lambda over let over lambda over let over lambda.
Okay. That
constructor factory.
Yes, you can certainly have a constructor factory. Oh wait, I forgot to splice this guy because this guy can't just be. This needs to be that. Yeah. Now I can.
And then the body of the labels is call n with mapcar of second of letards.
Wait.
I'm gonna take a wild guess.
Kedar. Yeah.
Catter, yeah, second.
Kedar.
You need a comma add on that. I'm almost certain. Not reading the source, but I'm almost certain that
yes, you do need a comma add. Yes, you do need a comma add. Good show. All right. This is ready to be compiled, and I wrote something wrong. Comma inside a.
Comma not inside a. Your body there isn't in the labels form.
It's not? I thought it was.
No, the body of the labels isn't actually inside the labels.
Ah, got it. That's why. All right.
Yeah. A single slurp from if your cursor's on the labels form, on the labels symbol.
Let me just make sure all my. Yeah, that's wrong. Hold on. This. Hold on.
Yeah, your indentation might be screwed up.
Yeah, that's why.
Oh yeah, there you are.
I hadn't.
No,
I
that's
still not right.
Yeah, remove the close paren on the labels and move it to the end of your def macro.
Okay.
Or slurp forward.
Yes, that.
Okay, move K, slurp
Space
forward.
K, slurp.
Slurp. I'm just trying to look at. Slurp is
S.
Okay.
There you go, and that's what it should look like.
Yes, that is what it should look like. I was wondering why is it saying that it's not in the labels? Okay. All right. I need to. All right. So one example that he wrote with this, which hopefully I can do without actually, is let. I think he did fact and was it an n? No. I must have messed that up.
No, yeah, he wraps that in a defun.
Yeah.
He says defun and let fact, and let fact and n.
Yeah, defun. Yeah, that's what it is. Defun fact. And then he did a nlet fact. And hopefully I could get this. P.
Your def macro. Don't use and rest, use and body.
Yes.
For the sake of the indentation. And now re-indent that defun, please. Not that defun, your new defun.
Oh.
It's indented wrong. Control C Alt Q.
Control C
Alt Q.
Q. Nope.
Well, that's the Emacs binding. I think it just equals a...
Control C Alt Q should still be bound. It's not like that gets unbound by something. That's weird. But yeah, it equals F ought to do it. That's not indented right. I know it's not.
Nope.
Yeah, it's not indented right.
Equal AP will do it.
Yeah, equal AP.
Equal AP?
Yep.
Equal sign AP.
There we go.
Much better.
I was wondering what the... Okay. And fact... what is it? I think it is N... What am I messing up here? I always...
N times fact of N and N minus 1.
Yeah. Fact of it. Yeah, that's right. Times, it's actually times N fact. It's
1 minus N. Or, actually, no.
No, not decaf. Not decaf.
1 minus N, yeah. This one.
No, not that.
And 1. There.
There you go.
Yeah, that should do it.
Yep, that should be it. Now let's see if this works. Quit. Yep. And let fact. 5. There we go.
Looks right. Yeah, now go over to that and macro expand it inline.
That's... Okay.
Not the defun.
Yeah, that's
Not
what
the defun.
Yeah, that's it. Yeah, there you go. Okay. And as you can see, it just generates a labels function and then passes in N. This really, when I read this the first time, this NN really bothered me. I was like, this is a new N that's scoped in, that's being passed in, and then this is the N that's being actually being passed into the defun. And I was like, okay, this is, I see what he's doing. I would have named it something else, but, you know.
I suppose.
Yeah, you could.
I'm just not used to this N comma, this NN, you know, kind of notation. There,
well, so if you macro expand that though, right? So you see how they're now the two N's are in different places?
Yeah, they're in 2 different places. You're right.
Yeah. It's much less jarring when you read it like that, but it's also much more verbose.
It's much more verbose, right. That's right. I mean, that's why we created the macro in the first place.
Exactly, yes.
Couple things that...
Does he give a tail recursive version of that? I forget.
There is no tail recursive version.
Yeah,
Can we take a moment to write a tail recursive version?
Yes, we could take a moment to write a tail recursive version.
Okay. Yeah.
Okay. Quit.
So Q out of that.
Okay, let's do defun. Actually, I'll do def macro for the because you're gonna write it into def macro, right? Or are you gonna?
No.
Oh, okay.
No. I'm gonna write it using nlet.
Okay. Nlet fact. I'll say tr to say that it's tail recursive. All right. All right. So nlet fact tr is our tail recursive version of this this function. Okay.
Yep. So nlet fact.
And
we're going to have 2 parameters now, N and an accumulator.
Okay. Oh, all right. And I think I have to also say 0, right?
It needs to start as 1, actually.
Yeah, that's right. Okay, and of course we just start with if 0p, this is just us returning the accumulator. Otherwise, we, what is it? It is fact n minus 1 times ACCN.
Yep.
All right. And this guy should give us also 120 if I wrote it right.
But it will consume less stack space.
It'll consume significantly less stack space.
might consume less stack.
Might consume
Yes.
less stack space. It has the option of consuming less stack space.
A smart compiler will work with the original version there, and optimize the tail calls. But it doesn't have to. The scheme version will always. It's required by the standard to optimize tail calls.
Yep. There's actually a version of this macro in Serapium, which only works for tail calls, but it's designed to optimize them itself.
So internally, it recognizes where it could do a tail call and it'll optimize it.
No, it only works if you use it for tail recursion, and it doesn't use labels at all.
It doesn't use labels.
It just generates a loop.
Oh wow!
It just generates a loop.
All right.
It causes all kinds of problems if you try to use it without tail recursion, though.
Got it.
So, and it, as far as I know, it doesn't have a detector for if you're using it incorrectly, so you have to be a little careful about that. But if you want to write a loop tail recursively in nlet style, it'll do it, and it's guaranteed to optimize it. So, preferences.
Yeah, certainly. There's plenty of other examples of him going into macros and adding more complicated macros, but it follows kind of the same kind of review that we've done in the past. One of which, of course, is using gensim. This is something that I'm just going to bring up because he uses let gensim quite a bit instead of with gensim. So with gensims is I would prefer if folks are using with gensims.
Well, his version does have a few benefits that with gensims doesn't provide.
Okay, could you?
I'm sorry. I'm thinking about once only. With his once only version, since it's written in terms of his with gensims function, you can actually refer to the original variable. You can. What page is that on? I got the book right here. Let me just check.
Yeah, I'm actually trying to get us to once only because I think once only is a very important macro that we should discuss to understand.
It's also a headache.
We might want to discuss with gensims first.
Yeah.
And actually walk through his iterative process there of defining that before we define once only, because then you'll see why he actually did it that way, because it does introduce a couple new features that the traditional once only doesn't provide. Okay.
So let's start then. Let me go and implement then. So the example that he used gensims for is him actually writing a three-way if. If you guys aren't familiar with the three-way if is like there are functions like stirncomp in C, and in other languages they call it now the spaceship operator, which is basically the less than, equal, greater than. And this operator in newer languages, one of which actually I think it's going into Python's new version, it compares two strings or two values, and if they're equal to each other, it returns 0. If the left-hand side is greater than the right-hand side, it's -1, and if it's the other way around, it's 1. And you can tell which side matches based on the condition.
Fairly certain it is actually only defined to return negative if the left-hand side is greater and positive if the right-hand side is greater. Actually,
let me make sure that's the case.
Don't think it's defined to be exactly -1 or 1. He might have defined it that way, but in general, like the CMP functions or the three-way comparison operations tend to only say
negative
if it's
no,
left
actually,
side,
I think he
positive
did
if it's
that.
right
I
side.
just misread that. Yes, you're right. It's negative or positive of the number, the difference of the characters, right?
You don't always have an actual difference to work with, but yes, if you're the simple way of implementing that for integers is just right-hand side minus left-hand side.
Yeah.
If the left-hand side's the bigger one, it's negative. If the right-hand side's the bigger one, it's positive.
Right.
You know, but for strings, it's more complicated.
And so this spaceship operator is kind of useful. I don't like the fact that they call it the spaceship operator, and I don't like the fact that they're adding it. But because a function could just do it. And I don't see what this buys you. If I see 1.3 in code, like, does this actually help people in terms of readability? Maybe, I don't know. But it's certainly useful as a function call or has an operator. And what he created was a very simple example of actually implementing this. And he then leverages GenSim to actually help him do the comparison. So, not defun, def macro. So we're creating this three-way if, this NIF, that takes our expression, the positive value that we want to return, the zero value if they're the equal, or the negative value, right? And we create, essentially, before we start, we actually create a GenSim here, because we're going to have to we need this to actually preserve the value of the expression. So we then generate this guy G, and we then write three cases here. Our first case is, of course, and that's using standard cond. If it's positive, and is it plus p? Yeah, it's plus p. Plus p should show up, right? I could just use this, I guess. Plus p should work, right? Yes, plus p number. That's what I was wondering why it didn't show up for some reason. Plus p, and then we do positive. 0p, 0, and default I think is negative. Yeah. Negative. So we compile this. Complains for some reason. What? GenSim is defined but never used. Did I do that wrong?
You have you're missing a paren. Put the cursor at the end of GenSim.
Oh.
Move it over one to the right.
Oh yeah, just wrap that.
No, wrap it. Yeah, got it. That's right. That's what I needed to do.
Backwards. Okay.
Yeah. For some reason it just deleted a paren. Okay. Now if we write, a dumb expression, let's say, NIF, let's call it, 5 greater than 4, and then we got pos 0 neg, and it will return what is not a real. What is that? Did I mess something up? I didn't think I messed it up. Example. Could just certainly do this. It should have worked, but I don't know. Let's do the macro expand of this. Greater than 4. Okay, I'm doing something wrong here. I'm passing in an expression that that it does not recognize. Let me just say 5. Okay, so what I have to pass in is not a true expression. Right now, the way I wrote it, it will take in a literal of some value and then tell me whether it's 5 or negative. To actually go and do the execution. That's why I misread that. That expression is not something that needs. It has to be a value in that code.
That's weird.
That should not have to be a value. You are.
Yeah, I can't explain that by reading the code.
Why don't you double a vowel expression? Put another comma in front of it.
Well, that won't work because you're only one backtick down. You can't double.
Oh yeah, right.
You
probably have to vowel that.
Yeah, but that would happen at compile time, so it wouldn't have access to the local variables.
Like the value.
I'm just trying to figure out what's wrong with the generated code, because the generated code looks right to me.
Oh wait, because the expression is returning T or
true
nil.
or false? Yeah, T or nil. That's what it's returning.
Yeah, but then the condition is on the
plus 0 or negative. That's why
plus 0 or negative.
You're right, Michael, and that's why I was like looking at it. I was like, oh right.
Yeah, right. Yes.
The way it's written in the example in the book actually requires that the expression
you need an actual compare function.
Yeah.
Right. It has to return a number.
Exactly.
It just has to be some expression that evaluates to a number. That's right.
Right.
Yeah, it only took 4 of us to figure that out.
Yep. Fancy that.
One thing to note, folks, who are just tuning in or who are not familiar with some of this notation here, this just recall from our past discussions that #: means that the symbol is not interned. So it gets generated, used temporarily, and it's just like thrown away, And GenSym is actually built in. It will create unique symbols on the fly, and each of those unique symbols essentially is a symbol object that you could then reference inside the temporary code in the macro. And we'll be using GenSyms a lot, which is why I wanted to start going towards implementing some of these examples that Doug Hoyt talks into.
Yeah, probably not best to skip over his with GenSyms or with once-only macros because they're used throughout the rest of the book.
Yeah, it's very, very important. You're right. Now that I'm going through this again, because it's been a while since I touched Chapter 3 in this book, there's some stuff in here that we have to go through in order to really understand some of the stuff he goes in. where was it? He talks about, one thing about uninterned symbols that we noticed is, that we, if you remember, is, they're not actually, EQ to each other. So you can't have, like, you can have two uninterned, like, A, uninterned A, and they'll be pointing to potentially two different, locations.
They're defined to point to two different symbols.
Yeah, and they're defined to point. Yeah, you're right. They're defined to point to two different symbols. You're right. They get constructed and then they never get interned, so they get a different symbol object in memory that they're to return to. One thing that he talks about is this G-bang symbol predicate that he wrote. That I think is what we need to use to help print out results inside his NIF function. So let me just look at this just to make sure I'm not messing this up. Yeah, I'm gonna write this code in, and then you guys can discuss amongst yourselves, and then let's talk about this this one code. That's G-bang symbol P.
Oh, this is a fun one.
Yeah.
Lots of stuff to say about that. Mostly bad, but some good.
All right. Well, let me just pop this in here so that folks can look at this example, this code. So it takes in a symbol, and we check if it is a symbol, and
the helper function.
Great length symbol name of the symbol is 2. I don't understand why he has that, but okay. Then
there's an error there. You want to check whether the
this is 2.
Yeah, you got it. Yeah. Yep.
I figured. I saw that. I was like, oh, wait a second. Then we could do a string equal for the symbol name. We're just checking to see if the symbol name starts with a G-bang. And start 1 is going to be 0.
You can leave that off. That's the default.
Oh, that's right. That's right. It is a default.
You can just
I don't know why he. I don't know why he
he
specifies start 1. He does. He specifies start 1 as 0, but I don't know why.
Yeah.
Oh well, maybe just I don't know. You
So
don't have to.
this here is optional. He uses it, I'm guessing, as a just for completeness. But
Better readability. That's about it.
yeah. So this is basically, if you look at this this function, it takes in a symbol. It grabs its name from a lookup in the object. It checks to see if it is at least of size 2, the length of the name. And if it is at least of size 2, then it means that we can check to see if the first 2 characters, the substring
Actually,
comparison, is
check to see if there's more than 2 characters.
It's at least 2. That's what I said. It's at least 2, right? Oh no, it
It's
is
at least
more than
3.
It's at least 3. You're right. It is at least 3. At least 3 characters, and then if it's at least a 3-character symbol, it'll go and check to see that the first 2 characters are G-bang. Now, I don't understand this G-bang notation that he wanted to use throughout the book. I'm guessing he's trying to unify his symbol generation. I'm not sure.
It'll make more sense when we get to once only, which we probably won't get to today because this one's pretty involved. It's quite a long macro to write.
Yeah, certainly.
And understand on top of that.
So this one is G-bang. Once we get to... So G-bang is a pretty simple thing that we're going to be leveraging. And then we would actually use this to actually create this def macro G-bang, which will essentially, if I remember correctly, this one actually just generates all the gbang symbols and uses them in the body, right? Yeah, def
Yep.
macro name. Yeah, that's what it does.
It generates a let around the body that binds each of the gbang symbols to be gensims.
Gensims, right? And that's just giving you consistent naming across the generated code. But one question, and by the way, Elijah, I'm just going to mention to you the reason I'm using REST is because a lot of his examples uses REST instead of body in the def.
I'm not sure why he does that, but
that's
you're gonna have bad
exceedingly
indentation
frustrating to me.
with that.
I'm just letting you know that the reason I
can
use
see
REST,
it now. Actually, I have the web version of the book open, and it annoys me.
So I apologize for any time I type it in ahead of time. It's not my fault. I'm just looking at his thing and then don't realize, wait a second, he's writing a macro. He should be using body. No, hold on. Duplicates on whether these remove if not our
a deprecated function. Cool.
He's using a deprecate. It shows, the.
Well, in Common Lisp, deprecated can never be obsolete, so it doesn't matter.
We shouldn't want to show deprecated functions.
I can show you how to write the I guess, not deprecated version of remove if init. If not, it's just remove if with a complement.
Yeah, it's remove if. It's this, and then we could just do. I think I need.
It doesn't matter.
Yeah. So I'm gonna just because I don't want to write this function, I don't have this I think implemented here. For flatten, there's I think Alexandria has flatten already.
Yep.
So yes. I'm just going to go ahead and use Alexandria. So folks, as we go through this more of this book, I'm just going to use standard library functions just so that you guys can also get familiarized with stuff that's already available to you at your fingertips rather than implementing it yourself. Although implementing it yourself is definitely an education exercise that I encourage you to do. It's just when you're writing code, it might be nice to... Yeah. Flatten body.
One thing to note, if you're using flatten and you have other compound forms such as vectors, it's going to stop there. It's not going to flatten them. Alexandria's version anyway.
Is Serapium's better?
Serapium just uses Alexandria's. I do have a version that will flatten any compound structure, but it's not an Alexandria. Just something to keep in mind.
What do you mean by any compound structure?
Like if you have a list of vectors of lists of vectors of vectors.
Oh, okay.
Of vectors,
So
it's going to flatten all the atoms, all the leaves into just one flat list.
So it flattens vectors too. Got it.
Yes.
It should.
That's useful. Don't get me wrong. That's useful.
It's just something to keep in mind if you have something like that in your tree structure.
In fact, you could in principle make flatten work for any sequence type.
Yep.
There are only 2 sequence types, but you could make flatten work for any sequence type.
If you look in... No, I didn't add it to AFP utils. If you look in Golden utils, which is on my GitHub, I have a version of that.
Golden utils?
Yeah, well, it would be what? Apply in conc map to list of flatten on this thing. If it's a sequence, you do sequence P, and then you do that would work for any sequence.
That can work for any sequence.
Yeah.
I have to go read that code. Actually, it's basically the base for. I mean, you can use that to implement flat map too, right? Then.
Yes. Well, flat map is slightly different. Flat map only removes one level of flattening. Only does one level of flattening.
Guys, have a look at the chat.
Have we been missing that?
Oh, shoot. I apologize. I should have the chat. Let me go and pull up the chat. 1 second.
I actually don't see any messages in there. My bad.
Hold on. I think he's talking about the live chat on the stream.
I only see one message there.
Oh, I see what he's saying. He linked to let of Lambda code.
Well, unfortunately, that message didn't... Oh, what were you saying?
I said he recommends using the production code. And if you look at what's at the GitHub link, you'll see that it's after the flattened statement, it's a lot different. It doesn't use the def macro, comma name, comma args.
Okay.
If you look at the GitHub production code, he suggests.
Okay, we'll go look at the GitHub production code. Let's switch over. Let me get to GitHub. GitHub. Let over Lambda. Specify that in Google. And let me share my screen with everyone. Give me a second.
Oh, he's using parse body. Okay.
Okay. So this is the foreign let over Lambda.
Yeah.
Okay. Just want to make sure. Thank you.
And you'll see his def macro / gbag is different.
Okay. Let me go and share my screen with you guys. 1 second.
Who recommended that?
Hoyt. Look at the last link I posted on the errata page.
Okay, that's not Doug Hoyt's GitHub handle though.
No. Look at the errata link for Let Over Lambda book.
Okay.
And at the top of it, he recommends using the production code, not the code in the book.
Okay, let's see here.
I see what you mean.
Errata.
Oh, he does. Oh, yeah, parse body.
Okay, errata, the production code.
Yeah, that code's going to be harder for us to follow for now, but he's right, strictly speaking.
Parse body?
Yeah, parse body, pulling out the doc string, pulling out any declarations, passing those through properly, all that stuff.
Let me see this one. OEC, def macro, G.
What we could exercise is trying to figure out why the production code is the way it is versus the one in the book.
Let me compare them side by side.
Okay, give me a second here. I'm gonna share my screen with folks who are watching us. Let me go to... Let me just get this to Lambda. And for folks who are watching, we are actually looking at this code on GitHub's, the foreign let over Lambda. I will go ahead and reference this GitHub repository in the links on this YouTube channel, on this YouTube stream once we're done. Let me share my screen.
Thanks for that. That's gonna solve a few issues. He
Thank
says
you
that
so
if
much.
you're using SPCL, you have to use the production code because it's gonna, hit some bug cases with how it handles quasi quotes.
Yeah. Thanks so much, Richie.
Thank you.
Let's see. Let me share my screen with you folks on this guy. Applications. So now we're looking at this def macro G here. Parse body. I'm actually kind of curious about parse body. I don't remember parse body right now.
It's from Alexandria.
Yeah.
It is from Alexandria. Okay, that's right. Okay.
Yeah, I guess they used packaged that.
Okay.
Yep. It's yeah. This is why you don't use package, people.
Yep.
Makes it harder to understand what's going on.
Yeah, use package is. I don't encourage use package. I actually like you doing package name : symbol name So
use
it's easy to
package
look at it.
CL, and that should be all, unless
Yes.
you're writing extensions for CL.
Well, if you're writing
Yeah.
a package, you should just say def package and say UCL, right? I mean,
Yeah, only UCL, but only UCL. But
unless
yeah,
you're like shadowing functions from CL or something to extend the language in some way.
yeah.
So the reason why they use parse body there, right, is because they need to have so in the original code from the book, right, the body that you pass in gets wrapped in a let.
That's right.
Within the generated code. In the generated code, the body you pass in gets wrapped in a let.
That's right.
That's disadvantageous for a couple of reasons. Basically, it means that you can't supply a doc string or declarations for your stuff. That doc string or declarations, so because like the doc string has to be the first form in the body of a def macro, right? But you no longer have control over the first form in the def macro because all of your forms are being wrapped by that let expression, right?
Yeah,
Does that make
that's right.
sense?
Yeah, that's right. Okay.
Similarly with declarations, you can't supply declarations that are scoped over the entire def macro. You can only supply declarations that are scoped over the inside of that let. With the declarations, I don't think it's as big of a deal because there's probably not a whole lot of difference there. But with the doc string, that is actually a big issue. And so parse body is basically taking the body that you pass in and pulling out the doc string at the start and any declarations that might follow it and separating those out from the actual code expressions at the end of the body. And then he's splicing those back together in a way that preserves that the doc string needs to be the first form of the def macro itself, and then the declarations should follow that right away, and then your code, your actual body code, your source, expressions, those get shoved inside the let.
Okay, I see. Instead of doing an Uber splice at the end inside of the let, he's actually splitting out the subsections of what ultimately could be perceived as a correct Lisp function or structure, and injecting them as part of the final macro. So he's making sure that the right stuff, it goes into the right places when the macro finally gets generated. Now, one question I have then is now I don't know if this is SBCL specific, but this shouldn't have worked in other CLs, would it? Like, could you have? Is there another common Lisp implementation where you can have a doc string and declarations inside of a let form?
No, that's not something legal anywhere.
Yeah. Okay.
If you tried to, so the declarations would have been fine because let can have declarations, right? But the doc string would have broken everything. If you tried to supply a doc string to def macro gbang, given the code in the book, everything would have broken. Well, it would have been fine until you tried to do both. If you tried, because the doc string, it would just get ignored. The doc string would just be a string expression, and it would just be ignored. But if you tried to put declarations after it, now you're doing declarations in a spot that isn't the first expression in the body of the let, and that'll blow up in your face. And so, using the code from the book, doing doc string and declarations would at best do nothing, and at worst blow up on any implementation of CL.
Okay, that makes more sense then. Because otherwise, if it was still legal, then this is a cleaned up version, certainly.
Right.
But
no, the other code is fine as long as you don't try and do doc string or declarations. And if he's documented it that way, it's unusual, but not, strictly speaking, bad. It's just you can't use declarations or a doc string. Unfortunate, but you don't tend to declare things inside of macros anyway. The doc string is a bit of an issue, though.
Why is the doc string an issue, though? What?
It's just that you don't have a doc string, and it's usually good to document your macros.
Okay.
Right? With the version of def macro gbang from the book, you just have no way of supplying a doc string.
Oh,
is what it is.
Right. Okay, that's right. Yes, you're right. It doesn't give you any way of documenting your stuff.
Correct.
Okay.
It's not strictly speaking syntactically invalid. The code will still work. It's just you have no way of supplying a doc string that'll actually do anything. Whereas this version will allow you to supply a doc string, and it will handle declarations correctly.
Very, very interesting. This
Yep.
so this is the one that we should then really follow. And it's leveraging a third-party library, parse body, that allows you to that literally just
Well,
does
parse
what it
body
does.
is just from Alexandria.
Yeah, from
again.
Alexandria. Is it using anything else? No, I don't think so.
I don't think so.
The only
I
changes
would
to that function.
I would actually suggest that we first work off of the original source, because he wrote it that way, because it's just easier to understand.
Okay.
And then if we feel the need, we can go ahead and replace it with this source. But I mean, I think I've satisfactorily explained why this source is different from that one.
Yeah, I think that's pretty safe, and I think it's safe to assume that the rest of the book doesn't have declarations in that macro.
So luckily,
or doc strings.
the majority
or doc
of the
strings.
examples in the book, at least when I last read cursory reviewed the code in the book, I didn't see any doc strings in any of the def macros.
It'll be fine. So
The book
it won't
is
cause
doc
any.
string.
Yeah, it's just, if we ever want to use this code for our own purposes, you would want to use this version.
Okay.
If you ever wanted to do that.
you seem to be underlining the if there.
No, I definitely don't have weird convoluted issues with this macro here. None at all. Anyway, I think it's a cool macro. Don't get me wrong. I just don't think I'll ever use it.
Well, it's, I think, important to understand this one.
Oh, yeah.
Just
I
because
agree.
then you could certainly leverage it to to get to the big macro that we should really, really understand, because
Nobody truly understands once only. You can say you do, but you just don't understand macros yet.
Well, they.
I sometimes spend half of an afternoon just with a whiteboard and the definition of once only, walking through how the heck it works, just because it's so mind-bending to me.
It's very, very useful, though, because if I understand once only, it basically tells you compile time. There's a variation of, it's essentially compile time evaluation. If I understood once only, it's not.
That is not what it is.
It's not. Okay, so I'm completely misunderstanding once only. All right.
Once only saves you from yourself. Once only saves you from double evaluation bugs.
Right. But how is it doing the double? I mean, I understand what it's trying to solve, but I always thought that the way it's trying to solve it is to compute ahead of time, to do the transformation, and then just reference the evaluation all over the code.
Yes, but that's not compile time evaluation. That's just making an extra local variable.
Okay.
What once only does is, for each expression that you want to only be evaluated once, it makes a new local, stores the evaluation of that, sets it up so that at runtime, that expression will be evaluated and bound to that local. And then it makes it so that anytime you would refer to that expression, you actually refer to that generated local.
Oh, okay.
Yeah.
Okay. So it
makes a bunch of gensims, and then it makes a bunch of binding forms to bind the expression to that gensim, and then it makes a bunch of binding forms to bind your variable to those gensims. So it has to have 3 levels of lets and loops in each of them, which is why it's hard to follow.
Well,
I understand what it generates, and I understand why it generates it that way, but I can't actually follow the code when I read it.
Okay, Michael, you were saying something?
Oh, I was just saying that his version, which uses with gensims, is a lot easier to read and understand, as compared to the traditional once only with 3 levels of lets, I think.
Yes,
Yep, 3 levels of let, and each one has a loop.
It's crazy.
And you have a bunch of double backticks all over the place too.
Yeah, so I mean, let's finish with gensims so we understand that first.
Alright.
Since it's written in terms of that.
So, this example, this def macro / gbang, it gives us now the ability to have consistent naming for his for the rest of the code that he leverages, and it also generates and creates a macro writing shortcut called that he calls automatic gensims. So
Yep.
The def macro specifically, according to him, the one that we're looking at right now, creates a DSL for macro writing. Now, he says to think about this guy as a function, which is something that I wanted us to at least talk about a little bit, instead of actually so that we can understand its execution a little bit. And the way he designs it, this code is, and I think Elijah did a great job describing what it does. Is we're flattening it, getting all the symbols, and then we go ahead separate. Well, in this example, I'm not going to go through how he splits it up, but he splits it up and then provides you now a function with the appropriate unique symbols, and then have docstring declarations and body. But later on, he leverages where is it? Actually, you know what? I think we skipped one thing here. That's good, actually, because we don't want to go through that right now. That's on read macros. Because we skipped reader macros there, but we could actually leverage this def macro gbang code. If I just switch back to my Emacs buffer here for a second, if you give me a moment. Where are you? Emacs. And let me switch over to Emacs. Share screen. Emacs. Okay. So we can now leverage this def macro gbang macro that he created to rewrite nif, which he ultimately uses it to make it a little bit more interesting. Although I will say up front that this new version of nif doesn't actually get rid of what we were talking about earlier, which is the function that returns some sort of number, either 1, 0, or 1, 0, -1, or some positive value. So
def macro G isn't done yet.
Def macro gbang is not done yet. Oh, yes. I have to specify one more thing here. This one is
over one more.
Yeah. Yes. Hold on. Let me just make sure that I get this. 3, 4. Yep, right here. Okay. Sims and
just splice in body under the let.
Body.
Or yeah. Should be right.
Yep. It should work. Boom. Alright. So now that we have this, we can actually go in and take... I'm going to just copy this code that we have here and just replace what we need to replace. Shift here. So instead of using def macro here now, we're going to just use def macro gbang to actually generate our nif. So this guy itself is now taking nif and our expressions, and we can now reference our, instead of this let being there, we get rid of this let here, and we get rid of, we now use gbang result. Oops. We're just replacing all of our debanged results. And he did this just to make the code, the macro generation code, a little bit more, readable. You don't have to worry about now not generating symbols, because defmac gbang will generate the symbols for you, localize them, and now you're looking at the actual structure of what you're actually generating. So it certainly makes things a little bit more usable. Let's go ahead and, I would say a good idea would be to, what was it? Undefined variable. Am I using it unquoted somewhere? Yes, I am. Because I am messing up. No, that actually should have worked. Why did that not work? Undefined.
Unmatched close parenthesis.
Ah, yes. That's right. That's why.
Well, no, because you still have the other issue. Macro expand the gbang.
That's what I'm gonna do.
Okay.
Huh. It didn't actually generate the symbols.
Huh.
Let me go back to. Let me just go look at that again. Maybe I messed up something here. Let map car symbol S generate symbols sims. So let me just make sure something here. So it's supposed to take symbols and then generate them.
Hit Q. Head back over to your REPL.
Okay.
Try calling gbang symbol P on the gbang result symbol.
Gbang symbol. Oh right. Open paren. Gbang symbol P on gbang result. Let's see.
You have to quote it.
Yeah, that's right.
Yep.
The heck? Hold on. I think I just messed something up here. Quote. Gbang symbol P. Quote. Says it's true. It might be that flatten there. It's probably not getting anything from that flatten.
Let me take a look at that.
Alexandria, flatten. Should have flattened it. But 1, 2.
Oh, I think I know the problem.
Okay, go for it.
It's not a nice problem, and it's just a theory. Copy the body of that def macro gbang.
Copy the body of this guy?
And flatten it. Not that. Sorry, the body of nif. Sorry, my bad.
The body of nif.
Copy.
Okay.
Copy and flatten the body of that, including the back quote.
Let me copy this. Okay, Alexandria.
Or just, yeah.
That flatten. Quote. Paste. Ah, shoot. It's space K. What was that slurp? It's
S.
S. Okay. This should now run.
Okay, try that. See what happens. I have a theory.
Ah, I see. Since it's quoted, it's not going to get G results.
No, it's a bit more annoying than that. Do something for me. Set F.
Okay. You want me to set up and get this one?
Huh? No. I need you to set F something.
Oh, okay.
I need you to set F print pretty to nil.
Okay, print pretty.
Star, print
Oh,
pretty star.
yeah.
Oh, but that won't work because the thingy, because of the. It's fine. We'll wrap it out of print. Star, print pretty star. To nil.
Sorry, not
Print pretty.
Sorry. Print pretty.
You're fine.
All right, got it. All right, and
okay. And then do open parens print space hash v
and colon
33. It's just a theory.
Reader error.
No colon 33, just 33.
Yeah, it's just hash v 33.
Okay.
Thought so. That's annoying. That's actually remarkably annoying, because I don't know of a good way of dealing with that.
This is actually mentioned in the errata, that the production code doesn't suffer issues on SBCL's quasi-quote.
How the frig does it pull Oh. Because he's not using the flatten in Alexandria. He's using a flatten that specifically knows how to deal with SBCL's quasi-quote.
He wrote that.
Oh, fun times.
Yep.
Fun times, yes. Very fun times.
Oh, God. All right.
Okay, so the way you solve this, and there is a way to solve this, is you pull in fair quasi-quote, then you switch your read table.
Okay, so you're saying that I have to quickly...
what that means is that anybody that wants to use this macro also needs to pull in fair quasi-quote and switch their read table.
Well, couldn't I just do that in the package? Like, because I have a def
Nope,
package?
because the person that's using your def macro gbang, right, they need to be using fair quasi-quote when they generate their source forms.
Right. So you can't have it internal to the package.
Nope. The problem is that the representation of quasi-quote at runtime is implementation specific.
Yeah.
That's the problem. And so you can't just flatten a quasi-quoted list.
Yeah.
Because the things that are unquoted will be... They could be anything.
Right.
So this code is broken, basically.
Yeah. And that's why I was asking... This is... Okay, so... Okay. This is good. This is good that we're going through this and then going through the errata, because now it tells me that we need to match some of the examples that are in the errata and update the Lisp code as we go through this book a little bit more. That's good.
Yeah, well, the trouble is, of course, that this is SBCL specific. This is an SBCL specific fix.
Yeah, he's using... Wow.
Yeah, do you see it now?
Symbols from
He's
SBCL.
he's using an unexported symbol from SBCL in order to extract the thingy inside of a comma.
Ooh.
Ouch.
Where?
Because SBCL represents unquoted expressions as a struct.
Oh, he is using... I did not see that. Oh, he's using...
He hacked something in to make it work on SBCL.
Yeah, he did. But he says that... What is this? Apparently older versions of SBCL... Oh, wait. SBCL and not old SBCL for L...
Yep.
So he had a version of SBCL where apparently this worked, and it was...
Yeah, SBCL must have
broken.
changed the way they represent unquoted expressions.
Okay. This is unpleasant, but...
Well, the thing is, he was depending on implementation-dependent behavior the whole time anyway.
Yeah. Yeah, that's a problem. But okay.
Yeah, this production code is maintained by someone else after Doug finished the book. It's not maintained by Doug himself. This book was written quite a long time ago, so...
This book was written in 2008, wasn't it? No, yeah.
Something like that.
Yeah, because it's right around the time that that Common Lisp had 50. It's 50 years of Lisp. Yeah, it was 2008.
2008. That's not too long ago
Yeah.
then. Well, a couple
So
years.
what about,
in
would
software.
it be easier to use the flattened code and the production stuff?
It would, but that would make the macro SBCL specific.
Okay.
Nothing wrong with that as long as we all agree to use SBCL, but it's kind of poor taste. There could be people who want to use, who want to follow along that aren't using SBCL.
Who are using, like, say, Allegro or Clojure
or CCL, or ABCL or ECL or Clasp, and it's possible that it'll just work on those because their representation of unquote is valid for Flatten. But it's also entirely possible that those implementations use some entirely different representation for unquote. So you can't just flatten a quasi-quoted list. It doesn't work. I
feel it's equally bad to make a macro that users are going to use depend on
implementation-specific behavior.
No, fair quasi-quote.
Oh yeah, on fair quasi-quote. Yeah.
Yeah, I think that's equally bad to have a macro abstraction require users to use some library like that.
I mean, it depends a little. It depends a little. In this case, I agree with you. In the if it's strictly speaking an extension to the behavior, then I think it's fair game. Because like trivia, for example, has an extension that lets you use quasi-quoted lists as patterns, but it requires that you're using fair quasi-quote in order to do it.
Yes.
Right.
But that's an extension, and it's not strictly necessary for the behavior of the package as a whole, and it's shipped as an entirely separate ASD system, so if you don't depend on trivia quasi-quote, you don't even pull in fair quasi-quote, so, all that stuff. Whereas this, it's basically integral to the behavior of the macro.
Well, that's
unfortunate.
Let's say we just copy-paste this production code here, flatten. It's guaranteed to work on SBCL and possibly other implementations.
So yeah. I think what would be interesting, and I think that I would probably make a note of it to look into later today, and that is making sure that flatten the flatten implementation, because I have I think I have Clasp, ABCL, and CCL on my system. I'll just test it against them, and if there are any adjustments that have to be made, I'll make them and then check them into my GitHub repository.
The thing is, if there are adjustments to be made, they likely involve internals of those implementations.
Right, which means I have to go do some digging. But right. I think it would be better.
I'm fine with that.
I think it would be better in the long run to have a flattened structure. Like, heck, if some of this is in, say, I don't know, Alexandria or something like that, I could make a pull request to update.
I
don't
think the Alexandria devs will want to have code involving quasi-quote in their flattened implementation. I don't know. Maybe.
I don't know either. It's just that if folks want to use, these kinds of techniques that, Hoyt is kind of encouraging, and even on Lisp, actually, the original flatten that Hoyt kind of added some adjustments to was from on Lisp. And
but I don't think on Lisp was using it like this.
I don't know if they were. I have to go and reread chapter 7 through 10 to make sure. But my point is if they use flatten, they need to have some sort of flatten library or implementation that works across as many implementations as possible, right? I mean, otherwise...
Sure, it would be nice, but at the same time...
How much effort do you want to put into it is the question, right?
Right, exactly. and I'm not even really a fan of this particular style anyway, personally.
What style do you encourage?
I just use with GEDSIMs or once only.
So I think moving forward, that is something that I agree with too, because it's just if some folks look at the book and they'll use techniques straight out of the book rather than leveraging other things. It might be nice, and I'll make a note of this too, to try and map some of these code examples to using kind of standard library functions that we're familiar with.
So the whole reason he writes this this macro with bang automatic gensims, he calls it, with bang symbols, is because he eventually gets to writing a macro called def macro bang. And what that allows you to do is it functions as both with gensims and with only. And by changing the symbols passed into the macro, you can control whether it evaluates, from left to right like a function would, or whether, only some variables are once only some are gensims. You can control the evaluation model of the macro just by changing a few symbols rather than, changing
Certainly,
the code.
but I think we could mimic that too with some of the standard libraries directly, right? I mean, we could write def macro bang with the same sort of semantics, but using.
Well, the trouble is the def macro bang is using the same flatten trick.
Okay. Right.
I don't think it is for the once only variables, actually, because those are all in the arg list of the macro, and so that wouldn't require flattening. Well, it would, but you wouldn't be worried about things that are quasi-quoted at the very least. However, yeah, I'm just reading through it right now. Yeah. Okay. So the automatic once only from def macro bang could definitely be re-implemented to not need flatten or need def macro gbang, and that would be nice, I suppose. But the automatic gensims is a bit
trickier,
non-trivial.
Yeah.
Yeah, it's non-trivial.
Got it.
Just because you need flatten for automatic gensims.
Right.
And they're, portable flatten is tricky. The thing is, this entire style where you rely on part of the name of a symbol to denote its semantics, I find interesting. Yeah, it leaves a bad taste in my mouth.
We could just, for the remainder of the study of this book, we could just say, use Alexandrias with gensims and once only. We're not going to lose anything by doing that.
Yeah, I think as we move forward, that's probably what we should do. But the once only macro that he did write is something that looks a little cleaner than the original once only macro that I saw in
It only looks cleaner because it has automatic gensims.
Right. So what I'll do, and this is going to be actually the discussion for next time because it's a very deep discussion, unfortunately. Is I'm going to take Peter's because Peter Seibel in Practical Common Lisp actually copied the entire once only macro that I've been studying at least. And I'm going to just post that so that we can go through it.
Can I show you guys something real fast?
Sure. Can you share your screen by chance?
Maybe.
I don't.
Well, I can share my screen. The problem is that it'll share both of my monitors.
Okay. Yeah, that.
And there's no real way for me to deal with that.
Okay, what do you want to show us? If it's a link, then if you can post it somewhere, I could then post it on. I could show people on the screen.
It's actually just a variation on the NF macro.
Oh, okay, cool. Okay, I'll write it. Okay, give me a second
Okay.
here. Let me go take the keyboard
Sure.
here. All right, here I am.
You'll have to share your screen again.
Ah, shoot, that's right. I keep forgetting that I have to share my screen in 2 different places.
Yeah.
Glories.
That's the trouble.
That's fine. I have to figure out a way of doing that. All right.
Okay. So if you take the NF macro, the original one, and just copy that down real fast.
Okay. 132. All right.
Okay. Now, as a last step, write a third inner let. So wrap the cond in yet another let.
Which oh, the cond? Okay.
Yes, wrap the cond in a let.
All right.
Which says let, or so you have to comma you have to put a comma before that let.
Okay.
We're unquoting that.
All right.
And then you have to quasi quote the cond again.
Okay.
It's always a bit of the fun little dance that you have to do whenever you write this out by hand.
All right.
And now let expr be g.
Like this?
No commas there, because you're already unquoted.
Okay.
Just let expr be G.
All right.
Now go to all the places where you use G and replace that back with expr again.
Okay.
So comma expr. You have to unquote that because you're quoted again.
All right.
Okay. So now re-indent that code, please.
Yes. AYP.
Control C Alt Q.
Well, I did control. There we go.
Yep. Okay. So that is once only. That's once only on expr.
So let's read through this. So we created a new generated symbol.
Yep.
Then we assigned that generated symbol to whatever expr was originally.
Yeah, so we make our expansion bind that generated symbol to the result of expr.
Okay, I see what it did. So that generated symbol is now the evaluated version of expr, and now we're reusing the original symbol to the result. Okay.
Yes. Yep. And that's once only.
That's cool. So now you're guaranteed now whenever you're referencing that variable in the code, it's going to be the result of what its original evaluation was.
Yes.
And that's important when you pass in side affecting functions to a macro.
Yes. Very much.
Very much. Yes. This is where I saw where it was. I think even Peter Seibel and Peter Norvig both actually mentioned in their books that the side effects. This is very useful when you're dealing with side effects. Side effect code.
It's important when you're dealing with side effects.
That's really its only purpose, right there.
It's to.
But if you're writing in a very functional, in an immutable, like a manner, in the sense that you're only passing in values, then this does this kind of.
It won't change the behavior, but it might change your time complexity.
That's also a good point. I mean, that's also a benefit, right? If you can change your time complexity because you're making it into a constant or whatever, it's fantastic.
Yeah, you're not evaluating twice.
Yeah, you're not evaluating twice, right?
Well, so it won't change the time. Well, it might change the time complexity if the thing you're doing double evalod is a recursive call.
Yeah.
Maybe. I think. Yeah.
So when we generalize this, and I'm going to show the code on how this does it in a general sense next time. Keep this structure right here in mind. I'll check this in for future, so for folks to actually review it. And then next time, next Saturday, we'll go through once only and start going through hopefully some pretty cool other macro stuff that in chapter 4, which is on read macros. So next time we'll be covering read macros and once only. So chapter 4 on the syntax. For folks who are reading chapter 3 right now, wondering if we're going to be covering duality of syntax, I personally don't think so. Just because, I mean, we'll talk about referential transparency a little bit, but towards the end of that section, Hoyt gives his opinion on whether or not earmuffs are necessary or not, and I'm not entirely sure that's necessary up for discussion.
Just using a very opinionated guy. I'm glad we're covering this book though, because it's still one of my favorite books all time.
I mean,
sometimes he hurts me inside.
He does, yes, but at the same time, like the code he shows in this book is simultaneously really cool and kind of gross.
Oh man!
It explores a lot of really neat stuff. But in a lot of places, he does things that just make me kind of uncomfortable.
Oh man! No, I just want to thank you guys for joining us for today. Yes.
Would it be all of chapter 4?
It'll be. We'll try and get as much of chapter 4 in as possible next time. Provided that we don't get sidetracked with any bugs or errata that's in the book. But Richie, thanks so much for mentioning the GitHub page. I will go post that on the YouTube stream so that other folks can actually reference that, and I will even post the errata on the meetup page when I update it to include let over Lambda as what we're covering now. So until next time, thanks for joining us. I'll see you next week.
Bye then.